Welcome everyone to our technology lunch. Today in English and with Stefan Tilkoff discussing a taxonomy for microservices. We can agree to many good traits of microservices like independent deployment, choice of implementation, details, polyglot persistence, stuff like that. But there are still lots of different approaches to microservices. Self-contained systems, Netflix style, event-driven, and so on. So what Stefan is going to do is he will look at all those differences and diverse approaches and is trying to categorize them and highlights different benefits, downsides, and so on of each implementation style. Not sure if Stefan needs an introduction, but I'll do it briefly anyway. Stefan Tilkoff, a co-founder, principal consultant, and CEO of INNOQ. If you have any questions, please just write them in the YouTube chat. We will discuss all those questions afterwards. I believe we have 15 minutes time after the talk to go through all the questions. And yeah, without further ado, welcome Stefan.
Thank you very much, Sven, for the nice introduction. You basically summarized my talk so well that I actually don't really need to give it anymore. I'll do it anyway because everybody expects me to. But essentially, I think you made a great starting point by pointing out that there are many things that people can agree on that are very, very similar in most microservices approaches and are identical in most microservices approaches. Even though they differ, they can mostly agree on certain traits at least. And I've started I want to start my talk by summarizing those things. So let's first talk about what everybody thinks is similar in different approaches for microservices. So one thing I think that everybody can agree on is that we're focusing on one thing. If we do microservices approach, then the idea is to focus and to concentrate our efforts on one particular aspect of the thing we're building and to categorize that into different subsystems, submodules, and those modules, each of them are executable things that focus on this one particular thing. Many people know this as the Unix philosophy, do one thing and do it well. Everybody can agree on that, although nobody can agree on what that one thing actually is or what focusing on one thing means in particular. One thing that is, I think, also something that all microservices approaches share is the idea of autonomous operation. You want to be able to put something into production. You want to be able to start it up, shut it down, redeploy a new version, start it again, and you want to be able to do that with each and every microservice on its own. What you can do in operations, you also want to be able to do in the development. You want to have maybe different teams or different people responsible for different microservices. So if one person is responsible for one microservice, they shouldn't step on the toes of somebody else who's responsible for a different microservice. You want to isolate development as much as possible. And I already mentioned in the context of operation that you want to be able to put stuff into production independently of each other. So one service should be independently deployable. In summary, you get, or what the claim at least is of microservices is that you end up with more localized decisions. You don't have to agree on everything everywhere with everyone. You can make localized decisions and choose a local optimum for whatever it is that you want to achieve. Now, with those common traits out of the way, what are the differences? I think the major difference, the most important thing that people do differently with different microservices approaches is the matter of size. I think what this one thing is varies mostly in how large you make that particular context. Is it one very tiny thing that you focus on? Is it a huge thing of correlated functions that you bundle together as one microservice? So most of this talk is going to focus on the difference in size with different microservices approaches. So let's start with the first one. We'll go from the smallest to the largest, and we'll start with this event handling thing that Sven alluded to in the introduction. If we're looking at a device event handling thing, like for example, you're collecting events originating from thousands or even hundreds of thousands of small devices all sending something to the cloud, then you might end up with an infrastructure, with a setup that has small event handling services with different purposes within this event handling infrastructure. So for example, one kind of service might be responsible for handling event validation. Another one might do some transformation of the data formats of protocols. One event handling service might create new events. So that's this sort of fan-out approach where one event might lead to maybe a dozen or a few hundred other events that are then handled again by the event handling infrastructure. Inversely to that, you might actually aggregate, summarize some events and create new ones as a result from that. So that's sort of a fan-in kind of thing. You might store them and relay them, and you might have lots of things all triggered by this event handling method or methodology. And the key here is that each of those services that we're talking about here are really, really very, very small. They're basically, if you want to get down to the actual definition of the word, if you really want to talk about microservices, then you could argue that this is the only thing that actually deserves to be labeled that. It's the only thing where the things are really, really micro, super, super small. Most people have started to call this something like a function as a service approach, right? So each service is as small as maybe a few lines or maybe a few dozen lines. It really just does just one super minuscule thing, and that's all it does. So as small as possible, a few hundred lines or even less depending on the language you use, triggered by events and with a lot of asynchronous communication. That is also key to this particular approach. You have those little handlers that do their own thing and then they're done, and then another handler might pick up. And you can see this approach in a number of different examples. So one of my favorite speakers on this topic is Fred George. You might, if you don't know him yet, I strongly encourage you to look up his talks. There are a lot of videos on YouTube. And any recent of his talks, or not even those recent anymore, always have this aspect of these super small services that are combined to do something more interesting. In the serverless space, for example, the AWS Lambda space, we have all of these little functions as handlers registered within the infrastructure, which brings me sort of to the consequences, to some of the things that you have to take into account when you choose this particular approach. So the first one is that you have this shared infrastructure dependency. In the case of AWS Lambda, that would be AWS and the Lambda infrastructure and all the services and all the handlers and all the topology that you rely on to get things working. In the end, your services might have the same interface, like an event handling interface. They might be involved multiple times during the handling of a single request, if request even makes sense in this particular scenario. So you'll end up with multiple invocations of the same handler or similar handlers, depending on the topology that you have deployed there. In a certain way, you could argue that you have application logic in the event handler configuration. So a lot of what you would expect in a traditional approach to be part of the actual business logic that you implement in some high-level programming language might actually end up in some YAML file describing the actual topology of all the event handlers, the registration points, and the triggers, the trigger definitions that decide when or when not to trigger something. And you could, if you want to be positive, call this what happens emerging behavior, because you can't be 100% sure what happens. I mean, probably everything is still deterministic, but what determines what happens might be very, very complicated. There might be lots of timing issues. There might be lots of things that happen just because things correlate in a certain fashion at this particular point in time. And you might end up having a hard time figuring out what actually happened. So that is, to me, the major downside of this particular approach. I'd be very interested in your feedback on this, whether this is, if you have tried something like this, whether you actually ran into problems because of this. But I have the strong feeling that if you want to be negative, you could call it database triggers, the cool version, and you'd have many of the same problems, like all of these things distributed across a number of different places, ending up to create some behavior that you maybe expected, but maybe not. One of the cool things, especially if you do it in a cloud-based scenario, is that you have this build per request model, which I think is a very interesting aspect from a cost perspective. On the downside, you might end up with unpredictable response times. So in summary, this function as a service approach to me is very interesting. I think it very much deserves the name microservices. That's the cool part about it. I think It works very well, definitely in small scenarios, in proof of concept scenarios, in scenarios where handling tons of events is what you're after. I have my doubts as to its scalability in terms of the size, the amount of business logic that you can force into an infrastructure like this. So with that, let me move. Okay, so it seems we had some issues with the slides. In fact, I'm not 100% sure we have figured those problems out yet. So if everything breaks, if we still can get it to work, we'll simply do this thing without slides. That would be my suggestion, so that you don't waste your time. So a very quick check. The slide that I can see in the stream is called product detail page, but that's not the slide I'm showing. I'm showing a different one. So it still seems we have a problem here. So I'm asking our director, can you just, put me in front and I'll just do this without slides? With Sven or without Sven? I don't think Sven minds. Okay, so let's do this without slides then. So you probably saw me or heard me talk against this one title slide. So essentially, hope maybe you got a little bit of what I said. Otherwise, I'll summarize it very, very briefly. So the first version of microservices that we can talk about are these super small ones, the ones where we actually end up with these little functions. And to me, the most important distinctive factor here is that when we have this super small function, something else needs to take the place of what would typically be a lot of business logic written in some high-level programming language, and that essentially will be the configuration for the infrastructure that actually runs all of those handlers. And I have doubts that this is something that's going to scale if you have a lot of business logic. It'll work perfectly if you have very little business logic, but a lot of scaling to do and a lot of infrastructure that you can reuse. So I'm not trying to diss this, to completely make this make this appear a bad thing. That's not what I'm trying. I'm just pointing out this particular distinction. So let me move on to the second approach. The second approach would be what I like to call the Netflix style. And that is essentially what most people think of when they consider a microservices approach. In this particular approach, you still have things that are quite small, but typically they are a little larger than the first example. Those are not little functions. They're mostly little executables, and typically they handle HTTP requests or some other sort of protocol that allows for remote invocation of some kind. So with an HTTP handler, inside of them, they typically bundle like a little executable application, like for example, an executable Java jar, or maybe a little Go program, or whatever your language of choice or technology of choice is. And that particular thing will be able to handle an incoming request and typically handle it synchronously. So an incoming request will be handled by a little bit of business logic, and then a result will be returned. But to actually produce that result, that particular service might end up calling another service, which might end up calling yet another service, and so on and so forth, until you finally get back a result. That, of course, creates this network, this series of calls, like a distributed call stack. It's very similar to what many people did a while ago and called it SOA, service-oriented architecture. You have this vision of little services that can be built so that they focus on one particular thing, and you invoke them, and they invoke other reusable services. And in a microservices infrastructure that's built in that way, you typically end up with a lot of synchronous calls, and you end up with a lot of, well, stability challenges, let's call them. So you'll have when you have a service that calls another service, obviously you have to handle what happens if one of them fails. And that creates, well, a challenge, but it can be solved with a lot of stability patterns. If you know Michael Nygaard's terminology here from his great book, Release It, this has been adapted to many infrastructure components. There are lots of things that help you handle the case where one of the services fails and you have to deal with that gracefully. It's also worth pointing out that this thing has become extremely popular because it was popularized by somebody who's very popular, and it's of course Netflix, as I mentioned, for this thing. If you want to look at those Netflix-style services, or as you could call them micro SOA services, then Netflix has been instrumental in popularizing this approach, and I think that is like a two-edged sword. I love Netflix. I'm a customer of theirs. I use their services all the time. I find them extremely impressive from a technology perspective, the stuff that they do. But the problem I have with Netflix is that many people who rely on Netflix as a role model don't run a video portal, a video streaming service for a few 100 million people. They run a completely different kind of application, yet take Netflix as their example for that, which I consider a problem. I always consider a problem if you reuse something without its context. And while that particular architecture might be a good choice for Netflix, it most definitely is not a good choice for many business applications, and yet it's still applied. So that would be my word of warning here. This is very popular. This is well documented. There are lots of blog posts. There's lots of technology that helps you deal with this distributed scenario where you have these tons of smaller microservices working in orchestration to get something done. I still consider it not a good choice for most cases. So with that, let me move to my third example, or my third category in my little taxonomy here. So the third example would be what I like to call DDD, for distributed domain-driven design. I like to call it that because it takes stuff from the distributed systems work that's been done using SOA and microservices and all of that, and it also takes a lot of inspiration from domain-driven design. Domain-driven design is a little too much to explain right now, but my assumption is that many of you will know it already. The key concept here is the idea of a bounded context. In domain-driven design, whether you apply it to your local application, to a native application, or to a distributed system, one of the key concepts is that you separate your complexity, your logic, your domain into smaller parts, in smaller contexts that each have a lot of coherent aspects that belong together but are isolated from each other. So you have, for example, maybe an accounting context and a production context and a logistics context in a huge application of some sort. And with that model, you end up with bigger things. They may still be small from relatively speaking, because they're only part of your whole system, but they They're definitely bigger than the Netflix-style services that we talked about before, and they're also most definitely bigger than the little functions that we talked about at the beginning. With that approach, if you make it a distributed domain-driven design approach, then you essentially end up putting each context into its own service. So the granularity of a microservices will be that of a domain-driven design bounded context. That means you have maybe not a few hundred lines, but maybe a few thousand lines. You don't have a single table or two. You maybe have a dozen database tables or whatever your database abstraction of choice is. You essentially have something that can deliver a lot of its functionality on its own. Something that can handle a lot of requests without calling to somebody else, which is, to me, the major difference here. If you have to communicate with other services, you typically do it asynchronously, not synchronously. You don't rely on somebody else to be available to give you back a result. So that is one major difference. Of course, you then need something to help you handle those kinds of events. But there are a lot fewer events than in the first example, because it's not your whole architecture that's event-driven. It's essentially just the synchronization between the different contexts that is event-driven, that typically has to handle business events in some way. So this approach, I think, addresses a different need. Whereas the Netflix-style microservices have been created by a company that needed to scale like crazy in terms of runtime scalability, this DDD approach is mostly driven by development teams that needed to scale. I'm not saying that Netflix doesn't have to scale. Of course, in terms of development teams, of course they do, but the complexity is different, right? Whereas Netflix has a relatively simple business logic problem. I'm not saying it's simple. Video streaming is hard, but it's not, it's not the kind of complexity in terms of business logic that you have in something, that appears boring at first sight, like, for example, a big life insurance policy administration system. I mean, that doesn't sound sexy to many people, but it has tons of complexity inside that requires a lot of thought on how to separate things into manageable units. And that is, I think, more what the DDD approach drives from. And it's also what you end up supporting better if you go for this DDD approach. Now, that is my third category. And you might have guessed that I like it a little better than the Netflix approach, and I have fewer doubts than with the function as a service approach. So maybe this is what I would recommend, right? Well, yes and no. In many cases, I think this is a very good choice, but there's one thing that bothers me about this, which is the role of user interface. In many architectures that we've seen in the last few years, people have done all this correctly. They've done their domain-driven design modeling. They found very good bounded contexts that allow for parallel development, but they mostly focused on the back-end side of things. I think that is related to the fact that most architects, most people who like to call themselves architects and who like to do architectural work actually have a background in back-end development, not front-end development. So front-end development needs to be treated like a second-class citizen. And you essentially end up with all of these services in the backend and then a huge monolithic front-end application in front of that. Like, for example, with a web application, typically a single page application that is built by one team that calls into the services provided by all of the smaller, or all of the other teams for each of the bounded contexts and the related service. That, of course, creates a problem because anything meaningful will always touch the UI as well. So you always have to talk to at least two teams to get something done. And that is something that many large teams, many project teams that are composed of maybe a dozen or 5 or 6 or 8 teams find highly annoying, because inevitably the front-end team becomes the bottleneck of the whole project. So this is where self-contained systems come in. That's an approach that I like a lot, and one that we've been trying to popularize, not only us but also us for a while. And that is essentially the idea that you use sort of the same granularity as with the DDD approach, but you bundle the user interface with each of the services. In essence, you end up with something that is definitely not micro, more like macro, and also not really a service because it has its own UI. It doesn't really need an API per se. It just needs something that handles incoming user requests. And of course, it also needs to connect to the other systems, to the other self-contained systems or large microservices, whatever you want to call them. In part, it'll do that by the same mechanism that that the domain-driven design, the distributed domain-driven design approach uses, which is events. But there's another mechanism that works very well, and that is front-end integration. So essentially, you connect the user interfaces of those different self-contained systems and move from one to the other as part of the business process that is being executed. So self-contained systems are sort of the largest variant of this whole thing. You could argue that maybe a self-contained system isn't really a microservice, it's something different. I don't really mind. Those are just words. In my experience, this works very, very well as a means of structuring larger system. And that is why I advocate using them, but it's definitely not the only thing. So that maybe is the last category then. And the last category is kind of close to the self-contained system, because if you think of what might happen there is you might look at a larger system context and end up with maybe 5 or 7 self-contained systems. You might end up decomposing one of them maybe into a smaller set of pieces that might be Netflix-style microservices, or you might choose the function as a service approach for one of them because it's extremely well suited to that. It has extremely high load and could benefit from an infrastructure that can handle events like AWS Lambda does. So they all compose. They're not completely exclusive or mutually exclusive. So you could end up with a mixture. But of course, you might also end up with just one self-contained system. So if your context decomposes naturally into just one thing, because essentially you just need one team, and that one team could very well just build one application that has its internal structure, but doesn't need something like microservices, then you would end up with a final category, which is the monolith. And that, I think, is not a dirty word. It's perfectly fine to build a deployment monolith. That does not mean it has to be monolithic inside. It can have lots of meaningful structure inside. In fact, what I think is it makes a lot of sense to build a monolith. In fact, it makes sense to build many monoliths. So a monolith, in the good sense, is something that has a good size. It's not too big. It is a right-sized monolith that has just the right size for you to handle. And then you have many of those things and you connect them very loosely and you end up with something that gives you the benefits of all of those different approaches. So, in fact, that is the most important thing that I wanted to give you as a takeaway. The takeaway is that none of these things, none of those different categories is good or bad in any way. They all have their benefits and downsides, and you have to figure out what your needs are. And that is true in many regards, in many dimensions, or from many perspectives. You have to look at the team size that you have, at the business logic complexity that you have, at the load that you need to handle, at lots of different things, and those different categories shine in different variants. So pick the one that matches your requirements, and then mix and match, combine as you see fit, and then you'll end up with something that'll actually be a good architecture in the end. So that's all I have. I hope it was possible to follow what I was saying without slides. And with that, I turn over to Sven in the hope that we have a few questions.
We do.
Cool.
Yeah, the first question is this the first attempt we have in our industry to build such an taxonomy?
Well, I mean, when you said, is this the first attempt, I was tempted to answer, of course not. Then it was qualified with a taxonomy like this. I'm not aware. I'm aware of a few patterns. I've seen microservices patterns by Chris Richardson and by other people who do something like that. But that is not exactly the same thing. I myself have done some anti-patterns, also not the same thing. I'm not aware of anybody trying to come up with a set of names for these different things. I think the few times I've done something like this at different conferences and talked to people within the community, they basically agree with the categorization that I have here. Sometimes people want to add something, sometimes people don't agree with the downsides or with the benefits that I claim or for these, but they typically agree that this is sort of roughly the space. I'm not aware of anybody else, but I would love pointers if somebody has them. I'd be happy to merge this with somebody else's work. This is essentially, it's not advocating one of them as the best or worst. It's mostly giving you people a frame of reference to say, well, this is the kind of thing that we do. We do this kind of microservices, because I think that's a useful thing to have.
Yeah, I also think it's good to see the broader spectrum with all the pros and cons, because, yeah, if you obviously INNOQ talks a lot about SCS, but we also do event-driven microservices. Absolutely. And I don't know if someone else besides Fred George does Fred George style microservices, but I think it's good to see there is a whole spectrum with a lot of pros and cons. So another question is, how does SCS with multiple deployable artifacts inside, depending on the quality requirements, fit into your taxonomy?
Well, one of the slides that I couldn't show was one that had a little fractal structure, right? You know, a thing including many, like having a one-to-n relationship to itself, that then again could have a one-to-n relationship to itself. So essentially, I think all of those different styles compose. It's absolutely possible to, for example, have a self-contained system that as a whole is built, for example, by one team. That to me is a very, very critical part of the idea that one team is responsible for a self-contained system, maybe for more than one self-contained system, but you never have more than one team being responsible for one self-contained system. But let's just assume that within the self-contained system, there are certain parts that need to scale differently. Like, for example, some parts, some request handlers within that system need to scale to a few 100,000 users, while the rest only needs to scale to a few hundred. Then you might end up separating your internal architecture into a number of scalable, horizontally scaling microservices internally that would handle that huge load, and the rest is maybe more traditional monolithic web application as part of this self-contained system. You might end up deploying the whole thing as one thing, but you also might have your internal deployment cycle. And from the outside, it's just one self-contained system. But internally, you might not have to release all of it at once. You might be able to release just parts of it because you make an update to maybe just the scalable microservice thing. This is really a sort of a hierarchy of architectures almost, right? So it's the high-level architecture that's spanning the whole system, the whole context we're looking at, and then there's an internal micro-architecture for each of those systems, which might in turn be the macro-architecture for somebody else, all a matter of perspective, relative to each other.
Yeah. Talking about macro and micro architecture, I'm just wondering, would you also mix microservices taxonomies so that you have an overarching SCS system, but you have like an event-driven part within one SCS?
Yes, I would. I absolutely would. Yes, if it makes sense, why not? I mean, one of the key ideas, independently which of these approaches you prefer, I think all of them have this idea that you don't have to do things the same way everywhere. That does not mean you have to do them differently, of course. I mean, you might even want to limit your flexibility for example, for complexity reasons, or to preserve skills, or allow for easier skill transfer or people transfer between parts of the system. Perfect. That's all perfectly fine. But you could, in theory, choose whatever is best for a particular item. That's the localized optimum, the local optimum view here, right? The best of breed view here. And that might be very, very liberating. So one example I like to give is many relational databases have very cool features. Like, for example, Oracle has had XML features for a very long time. You could use Oracle's super proprietary XML features to get XML out of the database, even though the database just stores relational tables. Now, if somebody made that a part of my overall architecture, I would frown upon that and say, okay, that is a very strong dependency to this particular database. Do we want to have that? Can we afford to be that tied to this particular thing? But if somebody makes that suggestion just for one tiny part that's completely isolated from all the rest, why not? I mean, if it doesn't work, if I have to move databases for some, I mean, this never happens. But if somebody ever changed their database from one to the other, you could essentially just throw away this one piece and rewrite it from scratch. So the fact that you can rewrite instead of having to reuse gives you a lot of freedom internally in each of those particular things. So you might end up having different choices. And that, of course, I think extends to the choice of architecture. Why would I have to choose the exact same 3-layer architecture, the exact same persistence layer, the exact same whatever framework it is. Why would I have to do things in the same way when things are different, right? I mean, maybe this self-contained system handles a number of documents with very limited functionality, just stores them, puts them out again, returns them, updates. That's all it does. This other piece has this very, very complicated rule engine in there. Now, why would I not be able to make different choices for those two parts? That's part of the charm of the whole approach, that I can set my mind to different things in different aspects of the system.
Okay. Yeah, Arne asks, actually one of my favorite questions, what are your thoughts on mobile clients? For example, native apps as a user interface for backends built out of SCS. This would break paradigm of each service containing its own UI.
That is very true, yes. So I think we have all of the problem in native applications. We have all of the problems in the front end that we have with them in the back end. I mean, you know, we can solve that internally. We can have a modular structure like we had Java EE maybe in the back end, right? We tried to solve that within a monolithic application. We tried to figure out a way to make that more modular. Of course, we can try the same with native applications, but it'll never be as good as having separate applications. It'll simply never be. That is the limitation of the whole thing, because you cannot reasonably suggest that people install 10 apps, right? Nobody wants to do that. You want to have a single app for something, if you want to have an app at all. So what I would question is exactly that. I would question, no, first of all, I would assert there is no good answer to that question. If I had it, that'd be great. It'll always be less than perfect. It'll always be some mixture of at least having a common release cycle for the damn app, because it needs to go to some app store and that'll take, I don't know, 2 weeks for the approval. I mean, you'll always suffer from that. You won't be able to not synchronize the release process of your app, because it is just one app that just has one release. So there's no way out of that. Now you can decide that there's a very small team just handling this release thing, and you leave a lot of it to the individual teams that can do a lot of modular development, but it has downsides because they're not as isolated as you want them to be. Or you could decide not to build a native app, which I actually think is the best choice in about 95% of all cases. Because most of the time you need a mobile web app anyway, and if you build that in a decent way, it's good enough for most people. And if you want to go the extra mile and also build an iOS app and also an Android app, then that's fine. But most people, if they had a decent mobile web app, would stop at that. Most people being, organizations and businesses, not end users. But okay, if you want to go the extra mile, then you have to suffer that. Or another option, you could go for a hybrid approach, where you essentially have only very few things within the application, not nothing, but only the stuff that really makes sense to have it in a native app. Maybe the stuff that's really only available within a native app because it doesn't make any sense in a mobile web app. But all the rest could just be reused web views from the mobile web app, so that essentially the teams deliver a mobile web UI for their own self-contained system, and that gets aggregated within the native app that people use. Again, none of these is perfect. My favorite answer would be, if you can afford it, don't do a native app. But again, I understand that it's sometimes not a choice. Sometimes, for whatever reason, you need a native app, or somebody who has more power than you believes that you need a native app. Or maybe it's your job building native apps, so why would you put yourself out of business? So those are all valid reasons.
Yeah. Lucas is asking, in your own experience, how are teams working with self-contained systems taking UI, UX decisions? So he's thinking of big differences in design and usability. That's
an excellent question. So what I've seen work very well is to have a team that takes care of this across all of the self-contained systems. So a team will have central responsibility, but it will not have central responsibility in the sense that it does all the UIs or determines every UX detail. It'll do this in a general fashion. So for example, a centralized team can build a style guide, typically a living style guide, where you can actually look at components, right? It'll build components that can be used by the individual teams. It'll essentially build a pattern library as sort of the executable version of the style guide, right? So, and that pattern library will have common ideas and common choices for many of the things that happen in the application. So for example, every time you have to select a customer, there's sort of a component that allows you to select a customer, something like that, or pick a date, whatever it is, however small or large those components are. And the fact that each of the self-contained system teams has the opportunity to use that stuff means that things, that user interface elements within the different self-contained systems will look similar. Maybe not 100% identical, but similar. And that is actually, if you look, for example, at Amazon.com or Amazon.de, that's exactly what happens there, right? You can see that it's basically the same thing, but not 100% the same thing if you go along different paths within the application. So the second thing is user experience. That is not necessarily a technical thing. That is more like what are the interaction models that I want to have? How can I get enthusiastically happy customer end users, right? How do I make end users really happy? That should be the goal of the user experience professional. So what they might end up doing is they might be part of the teams if the teams merit having their dedicated UX person within the team. Most often, I think they will be shared among teams. So there will be people who work maybe 20% or 50% in one team and 50% in the other team and help them with UX decisions. So it's sort of a mixture of some reusable components that are reused in different contexts and some expertise that is shared, but not the single team that does all of this, because that again would create the bottleneck that you want to avoid when you opt for one of those strategies.
All right, thank you. There is no new question, which is good, because then I have time to ask another question. The unavoidable, let's say unavoidable discussion, should I start with a monolith, or should we do microservices from scratch?
So the standard consultant answer, of course, is it depends. But let me say you should not start with a monolith, because that is more controversial. I think the common wisdom is start with a monolith, figure out whether you need microservices later. And I think there is a huge risk in that statement. So let me first say why I think it's a reasonable, it's a good statement. So let's say you're a startup, you have 3 or 4 people building an application. Then I definitely don't think you should start microservices, because your goal should be to have something that gives you user feedback as quickly as possible. You should build it as quickly as possible. And that's probably, I don't know, a Ruby on Rails app that you just start and get out of the door as quickly as possible to get feedback. That is really great, and that's a good thing. For many things that are small, something that can be reasonably built by 3 people or 5 people in half a year, you don't need a microservices architecture. Most people don't have the scaling problems that microservices want to solve or claim to solve. So you don't have to do any of that. But it is simply an illusion that you will start with a team of 25 people, build a monolithic application, and 2 years later decide, okay, let's turn it into microservices. That is a rewrite. That is not some. If it were that easy to build a huge modular application, then people would have done it. If it were that easy, nobody would have invented those stupid microservices. It is hard. It is almost impossible because of the connections that tend to form. If you have that many people working on such a large code base, then without some very, very principled way of separating modules into things that cannot talk to each other, same way that they continue to end up with something bad. So probably what I'm trying to get at is you should know where you're heading. If you know that in the end you'll end up with microservices, if you want to end up with microservices, then you should think of that early on. And it's probably a good idea to do that only for domains that you know well. So my sort of compromise statement is the first system that you build for something should probably not be a microservices system, because you lack the domain knowledge. But if you know the domain, if you know what it is that you're doing, then you can figure out how to build components, and then you should start that early on. You'll have to change your mind, you won't do it perfectly, but you have to start it early on, because otherwise it simply won't happen.
Yeah, thank you. Yeah, some people even wrote a book about breaking monoliths into microservices.
It is a tough thing.
Yeah, it's not something you just do. It's about time to close the session. Maybe one thing, there is work to do for you. So Peti Koch was asking, or basically was saying that this was a really great, we really need that taxonomy.
Thank you.
If there is an article or paper, which is published, which you can show around.
Yeah, at the moment, no. I have these slides that you folks didn't see. They're available. We can tweet them and put them in the links of this video as well. But there is no article where it's rewritten down. The most that I wrote about it is actually, I think, an abstract for an academic conference. But that's 1.5 pages. It's not a really in-depth treatment of the whole thing. But I probably should do it. Yes, I know. I probably should write something about it.
Good. All right. So thanks, Stefan, for the presentation and the Q&A. And thanks for everyone attending. Thank you, of course, to Thorsten, who is doing a lot of things behind the scenes and probably had some sweat during our technical problems. But everything went okay, I believe. Before I leave everyone from the hook, off the hook, I just want to say, please, if you haven't done it, subscribe to our YouTube channel. And of course, remember, next week we have another heavy hitter speaking, Gernot Starke, about quality-driven software architecture, next time in German. So just as a hint. And yeah, that's it from my side. Thanks and have a good afternoon, everyone.
Thanks, everyone.